Welcome to screencast number 2 for Unit 8, Lesson 3. I'm on page 454. Okay, we're going to talk about what the factors, atmospheric factors for global weather are. Okay, you've got three factors primarily: global winds, global pressure belts, and jet streams. Okay, these are factors having to do with the atmosphere that affect our global weather patterns. Okay, as we learned in Lesson 1, there are three major global wind systems, and those are the trade winds, the westerlies, and the polar easterlies. Remember that the trade winds exist between 30 degrees north and 30 degrees south, okay, and they generally blow from east towards the west, okay. The westerlies blow between 30 and 60 degrees latitude, okay, and they generally blow east. Why are they called the westerlies? Because the wind is coming from the west, okay, from the west blowing east. And then the polar easterlies blow between 60 degrees latitude in the poles, and they generally curve to the west, okay. They're called easterlies, again, because they're coming from the east, blowing towards the west. Okay, so those are our global winds. And those shouldn't be brand new to you because we talked about them in Lesson 1. Okay, so one of the first things that you need to realize, for instance, here, this is a great piece of information that they actually point out to you. The path of tropical storms are steered in an east to west direction because all of those storms generally form and exist between the equator and 30 degrees north or 30 degrees south. Okay? And so if they're tropical systems, they're going to be influenced by the trade winds. That's why they're going to move towards the west. Okay? So knowing trade winds, knowing how the westerlies and the polar easterlies operate is going to help you determine where weather systems are going to move in general. Okay, the next thing we're going to talk about as far as atmospheric factors that affect global weather are pressure belts. So now I'm on page 455 over here. Okay. All right, there are basically four pressure belts that occur at different latitudes. You have low pressure belts forming near the equator because warm, moist air rises. And at the equator, you're going to have a lot of precipitation and cloud formation because you do have warm air rising on a regular basis at the equator. So areas near the equator receive large amounts of rainfall. Okay, tropical storms also form in this region. Okay, the westerlies and the polar easterlies meet at about 60 degrees north or south latitude. And at those latitudes, you also have air rising again, and you get another belt of low pressure with cloud formation on a regular basis. Okay? All right. Between those, we have areas of sinking air. Okay? At about 30 degrees north and south, we have air that's sinking, and when you've got air that's sinking, you have higher pressure, and sinking air prevents a lot of cloud formation and rainfall. So you have a lot of deserts and things like that in these 30-degree north or south areas. Okay, it's not perfect, but those generally are where you're going to have most of your deserts. Okay. Also, 90 degrees north, 90 degrees south, the north and south pole. Those areas are also very dry areas. You don't think of them as dry because you look and you see frozen ice at both the north and south pole, but you don't get a whole lot of precipitation because, again, it's a high pressure area and you don't get a whole lot of cloud formation very often. Now, what little snow the poles do receive typically stays frozen. Okay, the poles can be thought of basically as cold deserts. Now, I want to go back to Lesson 1 and go back to this figure on page 424 because that's going to help you understand why we have these high and low pressure areas in the places that we talked about. Okay, so hang on, I'm going to zoom out and get this situated so you can see both pictures. So, all right, so this page right here is page 424, and that's from lesson 1. This page is the current page that we're on. This is page 455. Page 455 shows you your belts of low pressure and your belts of high pressure. Okay. Now, if you go over here to the globe, you'll notice why you have low pressure and high pressure belts. At the equator, do you see that the convection cells that meet at the equator, you have an area of rising air at the equator? Okay, warm air rises, moves either north or south to about 30 degrees north or south, and then descends. Okay, so at 30 degrees north and 30 degrees south, if you notice where the convection cells meet there, and you follow the arrows, they're moving down towards the surface. Okay, so that's sinking air. It's sinking, it's going down towards the surface of the earth. Okay, so you have rising air at the equator, that's low pressure, and that corresponds to our equator over here having low pressure. At 30 degrees north, we have air that's sinking. 30 degrees south, we have air that's sinking. And you notice that they've marked that as high pressure areas. Okay, over here, you notice that 30 degrees is marked as a high pressure area. Okay, follow the convection cells again to 60 degrees north and south, and you see that 60 degrees, you have rising air again, both in the northern and southern hemisphere. Rising air is going to be due to lower pressure, so you're going to have a belt of cloud formation consistently at those latitudes as well as the equator. Okay, you notice that you have low pressure marked at 60 degrees over here on this map, this globe also. And then if you follow your convection cells, you'll see that you have sinking, the arrows are pointing down if you follow them, at the poles. Okay, and they didn't label it on the poles, but this would be an area of high pressure again at the poles. Okay, because air is sinking and it's exerting more pressure on the ground. Okay, and you notice that the pole over here has an H for high pressure. Okay. All right. Remember that in general, this means that at the equator, where you have rising air, and at 60 degrees north and south, where you have rising air, you're going to have more consistent bands of precipitation, cloud formation, things like that. At 30 degrees north, 30 degrees south, you're going to more consistently have high pressure, fewer clouds, a lot less precipitation. Okay? Of course, your land is not evenly distributed throughout the world, and there's some other factors that influence this. But in general, your deserts are located right around the 30 degree north or south, and it's for that reason. It's because of the fact that those areas are subject to high pressure on a regular basis. Okay, so just as you think about lesson 3, you really kind of need to go back and refer to page 424 from lesson 1. All right, so back to lesson 3. Hopefully you've seen that I've made this note over here, and it corresponds with the globe that's beneath it. Low pressure belts are found basically at the equator and at about 60 degrees north and south. High pressure belts are found at 30 degrees north and south and at the north and south poles. Okay. Down here it's asking you, says visualize it. Circle the word rising or sinking in each caption to describe how Earth's major pressure belts influence the weather. Okay. Arizona at 32 degrees north, you're going to have, remember, at 30-ish, you're going to have generally sinking air and high pressure. Okay. Guatemala is further down here. It's not at the equator, but it's close. Generally, we're going to have rising air, lots of cloud formation, lots of rainfall. Okay. All right, we're going to go to page 456. All right, remember we are talking about Atmospheric factors that affect global weather. Atmospheric factor number 1 was global winds. Atmospheric factor number 2 was your pressure belts. Atmospheric factor number 3 are your jet streams. Okay, and again, this is not absolutely new because we've talked about this in previous lessons. We talked about this in lesson 1. Okay, all right, so jet stream is a narrow band of strong, fast winds in the upper atmosphere. The troposphere is the bottom layer of the atmosphere where most of the Earth's weather occurs. All jet streams flow from west to east. Again, I'll say this just like I said it in the previous lessons. We're not going to take the time to explain exactly why that is. I mean, there is an explanation, but it's kind of beyond the scope of our 8th grade science class. Okay. The positions of the jet streams shift with the seasons following boundaries. The jet streams exist between areas of hot and cold air. Okay. In the northern hemisphere, the polar jet stream moves southward in the winter. This is the jet stream that they talk about if you watch the weather forecasts through the winter, and they say that the jet stream may bring very cold temperatures or a cold front or whatever. It has more of an influence on our weather during the winter because it moves southward during the winter and it brings cold Arctic air south into the United States. Okay. The jet streams in general are just important because they help steer storm systems. Okay. And the position of the jet stream can also influence where thunderstorms and tornadoes occur. Each hemisphere has 2 jet streams, a polar jet stream and a subtropical jet stream. Okay. And remember, they all flow from west to east.